So when you're dealing with automotive applications, you need the right set of tools, and Tasking is a company that is addressing this particular space. So Roger, could you just give us a quick overview of what Tasking is?
Yes, thank you, Bill. So Tasking, we're an automotive safety software development tool supplier. And so we create compilers, debuggers, and high performance type tools for making your software as efficient as possible.
Okay, so with respect to automotive tools, how do these things change with respect to safety and automotive designs versus the standard off-the-shelf GCC?
Oh, absolutely. Thank you so much for the question. So Tasking uses their own proprietary Viper technology. So they're not an open source software provider. So we don't use, GCC or LLVM. So based on our standard technology and based on using ASPICE level 2, our tool sets are all automotive safety certified by the TÜV and very much focused on automotive safety.
Okay. Now you have standard set of compilers and IDE, debugger, and a bunch of other specialized tools. Is that correct?
Yes, that's correct. And so if you look at the Tasking portfolio currently, we have our tri-core tool sets, which focus on the Infineon Aurix, the TC2, 3, and 4. And we also now support the NXP S32K3, and our tool set, which is coming out in a couple months, will be supporting the zone architecture S32E and S32Z.
Okay, well, let's focus on the compiler for a moment because, obviously it's going to be compatible with the languages themselves, but, do you have any extensions, other things that may be different from, off-the-shelf compilers?
Oh, absolutely, we do. So based on our proprietary technology, we can do something, for example, called crosslink. And what that will allow us to do is if the application is being developed in like the current version of the tool set, like 6.3R1, for example, and your MCAL release notes say require you to use an object file from a previous version of the tool set, we can actually cross-link those two object files together so you can still just create one binary.
Now, standards like MISRA-C are important in this automotive space. Do you support those?
Yes, so MISRA-C and CERT-C is automatically kind of rolled into our IDE. Based on how our IDEs are designed, we have an IDE based on Eclipse, and then you can also run them from the command line through a standard make file, which also allows you to work in a continuous integration type environment, where you can do like Jenkins type solutions.
Mm-hmm. Well, you mentioned cross-linking, but you also have a linker script system. How does that work?
Yes, that's correct. And so Tasking has a linker script language, which allows you to, down to the object function or global variable level, you can place things into different locations in memory. And a good example that I like to use is a lot of times, let's just say, for example, you have an OEM and the OEM is requiring you to use a certain Ethernet stack. But they're also requiring you to use a target device. So if they're specifying you to use a microcontroller which has only 6 mega flash, but the Ethernet stack takes up 4 of it, and now you can't fit your application, in the additional 2. How can you prove that, say, to the OEM that you need a larger device? And so we can, with our linker script language, we can take all of the Ethernet code and we can group it all together. And then when you actually compile your code, it will basically say, how much of the available space is using Ethernet. So you can very easily show proof or evidence to the OEM that, your requirements are using up a majority of our system resources, which is pushing us into a larger device.
Okay. Now you have just one compiler, but you support multi-core heterogeneous environments.
Yes, that's correct. And so if you look at, for example, our Smart Code product, which supports the third generation Aurix or the TC4X, so there's 10 different cores which are available in the TC4X. You have 6 tri-cores, you have a Synopsys ARC core, you have the GTM core, which is from Bosch IP, and then you also have an 8-bit core for doing like current management or standby power consumption type control in the application. And so we have actual compilers for each one of those different cores within the same tool set. So you don't need to go buy, 3 or 4 separate compilers. You can just buy the one tool set and have a safety certified IDE or environment for developing your code.
Well, you recently picked up iSystems, which is in the debugging space. How does that meld with all the other stuff that you have now? And is it just software, or does it move into the hardware realm?
That was actually a very strategic and in my viewpoint an awesome acquisition. And so iSystem offers, they have a true FPGA front end on their blue box. So they have the IC5000 and the IC5700. And so with their blue box, they can work with the Aurora Gigabit, or they can work with true DAP, so they can run at 160 megahertz or up to 2.5 gigabits per second. They can do all of the traditional, like set breakpoints and do single stepping, but they can also do event chain. They can do full trace. There's a couple other different tools which are kind of integrated into the overall package. So you can do either manual or automated unit testing, full trace, full multi-core debug. So it basically allows tasking now to provide a system solution for both, the compiler tool set as well as the debugger to just ease the, the number of people that our customers have to talk to or interface with, for that system solution.
Certification and qualification are major aspects within the automotive space. Could you talk a little bit about how those tools and middleware might be addressing that?
Yeah, so all of the tasking tools are, as I mentioned earlier, ASPICE compliant. And so if you're not unfamiliar with the term ASPICE, it's synonymous with the US standard CMMI. And so we follow a very structured process, and all of our tool sets are TÜV certified. And we also have a what we would call our safety ecosystem, which is a number of different pieces, say, to kind of build a overall safety solution. So that includes things like safety manuals, security manuals, freedom from interference tools, our tri-core inspector tool, qualified CLIBs, all geared at making meeting the ISO26262 requirements as easy as possible on our end customer.
Okay. Well, you just mentioned freedom of interference. That's a term that a lot of people may not be familiar with. Can you tell us a little bit about it, as well as the tool and how it works?
Exactly. So if you look at, say, for example, some of these multi-core heterogeneous architectures, they have a lot of capabilities. So what the OEMs are doing today is, rather than having, say, 10 different ECUs, each ECU electronic control unit doing its own function, they're combining some of these functions together into one ECU. And if we use just a simple example, like in a cockpit of a vehicle, let's take like electrical power steering, and let's take a radio, and let's combine them together in the same ECU. So when you look at the safety cases of each one of those two different applications, if you have a radio, and if the radio is, say, not working correctly, it's more of a hassle, or it's a burden on the user, but it's not a real safety type issue. Whereas if you look at electrical power steering, if there's an issue, and if you provide steering torque when you're not supposed to, or if you need steering torque and it doesn't provide it to you, now you can't turn the vehicle, and you can actually cause harm to people around you or people inside of the vehicle. So each one of those two different applications has a different ASIL rating. And so electrical power steering has an ASIL-D, which is the highest rating. And when you look at the radio, it's like an ASIL-A or a QM type function. And if you look at the details of ISO26262, what it states is that there's two different options when you put these two different features together. One is that you can take the lowest, the QM application, and you can design it to be ASIL-D. Well, you can imagine if you take, a standard QM type application and go through the whole process of creating an ASIL-D, that's a lot of work. The second answer is that you can create them in separate partitions, and you basically have to prevent the radio from inadvertently affecting the higher level ASIL application. And so you can't, change variables. You can't, so the radio couldn't change, memory for the electrical power steering. It can't stop the tool from, say, executing its routines. And so what we have currently is we have what's called our safety checker tool. And when you look at these advanced architectures, they have a hardware implementation called a memory protection unit. And that memory protection unit basically can be programmed and enabled to not allow these, say, cross contaminations to occur between different software functions. The problem comes in, though, is that when you do have a problem and the MPU does throw a trap, those traps are very hard to debug, and they take hours and hours to debug. Our tool is a static analysis tool that basically runs before the compilation and build process. And so we can basically get 90% of these freedom from interference type issues before you actually enable the MPU. And so the overall software development process is a lot more efficient, a lot less time consuming, and basically requires a lot less resources.
Okay. Another one you mentioned that I'd like to hear more about is the inspector tool.
Yes, so the Tricore Inspector tool is, so if you take a step back and if we look at what a compiler is a software translator. So it's taking high-level C language and it's compiling it and it's translating it into assembly language. So in the end, it's just a software tool. All software tools can have issues or, what we refer to as software bugs. And so our compiler is no different. When you look at tasking, we've implemented what our issues portal, and this issues portal can be accessed by our customers. And that has all of the issues that are both found internally and externally, and they're all basically grouped and categorized. And when you go into the details of this issues portal, these different issues will be grouped in terms of their ASIL rating. How do you recreate this particular issue? How do you mitigate this issue? What versions of the compiler are where it's fixed, et cetera. So all that information is kind of contained. And so if we take, if we look at an example like an AutoSAR example, for example, if you're using like Vector or Trasos, and then you're also using MCAL, and you're doing it for an electrical power steering, you can have millions of lines of code. And so, so if you look at these millions of lines of code, how is our end customer supposed to be able to find one of these compiler issues? Well, in the past, it's been a lot of manual effort and a lot of manual work. What the Tricore Inspector does is the Tricore Inspector basically automates that, and it basically does it for you. And so what the inspector tool will do is when it gives you the issues, I mentioned the word mitigate. And so what is mitigate? So if we go back to our earlier example with Trasos, where you have to say use a specific number of or a certain number of compiler optimization settings when you build your code. So when Trasos tests, when Electrobit tests Trasos, they have to pick a certain number of compiler options that it's valid for, because they need to make sure that when they deliver their build that it's safe. And so they have to provide what they've tested it against. And so let's say, for example, you're using compiler options 1, 3, 5, and 7 when you're building the code. Well, those 4 options together may very well create one of these issues. And so what the Tricore Inspector will do is it will help you to figure out if I remove, say, issue 7 and only use 1, 3, and 5. Now this bug is not excited, and now you can go ahead and you can use the code as it is. Or the other option is if, say, Traso says, Electrobit says you must use 1, 3, 5, and 7, and we see that it's creating faulty assembler, then we have to provide a patch to correct that problem. So it's all about finding these issues and making the software development process as efficient as possible for our customers.
Very good. Well, to wrap up, could you give some recommendations to developers on the types of questions or things to look for in this type of tools?
Wow, that's a really good question. I think obviously if you're in the safety space, there's a fine line between providing say a process for qualifying your tool set versus providing a qualified tool set. So when you look at tasking, for example, we do all of the work for you. We generate the safety manual and the security manual to show you how to use the different options and which options are safety certified and which ones aren't. If you look at, say, some of tasking's competitors, they will provide you with a process, and they will say, if you want to qualify our tool set, you must do steps A, B, and C, but it's still, the onus is still on the customer to do steps A, B, C, and D. And so, you know, it's all about building safe and secure, repeatable software that won't, you know, in the end cause injury or harm to your occupants or to your customers. Yeah, that was a good question.
Well, thank you very much for the insights and covering what tasking tools are doing.
All right. Well, thank you very much for your time today, Bill. It was a privilege talking with you.